All right, section 7.1. We always start out the beginning of each chapter with a review and a preview. And what we did in the beginning of the course was what's going to allow us to have the discussions that we're going to have from chapter 7 on. This is where we get into testing hypotheses and using inferential statistics, which to me is like the heart and soul of what we do in this course. Everything's been leading up to this point. So in chapters 2 and 3, what we did was we used descriptive statistics to summarize data. We looked at graphs, at distributions and means and standard deviations. In chapter 6, we looked at some critical values, and we used the inverse normal distribution in order to determine what critical values were. We used the inverse norm, and I told you that if alpha is equal to 0.05, what would be the z-score that would give us that value? That's called a critical value. We did this for some common values. Z sub alpha denotes the z-score with an area of alpha to the right. So if alpha is equal to 0.025, the critical value then would be z sub 0.025, and that's 1.96. The 1.96 is close to 2. If we went away 2 standard deviations from the mean, what percentage of data fell within that region? 2 standard deviations is 95%. Okay, if 95% of the area is trapped in between these 2 standard deviations above and below the mean, what percentage or area has to be out to the ends? Because remember, we have symmetry with this graph. This is 2.5 out here, and this region over here is 2.5 as well. So that's where this number came from. That 0.025 represents 2.5%. Well, the 1.96 is the critical value that we got using technology. Before we had the technology, we just said 2. 2 is close to 1.96. We are going to be more precise now from here on out. When I ask for a critical value when alpha is equal to 0.025, I want you to tell me it's 1.96. It's always going to be 1.96 if we have a normal distribution, no matter what the mean and the standard deviation is. That critical value then has an area of 0.025 to the right. In this chapter, we're going to be looking at inferential statistics. The 2 major activities of inferential statistics are, first, use sample data to estimate the values of a population parameter. So we want to predict something about a population based on what we see with a sample. And number 2, to test hypotheses or claims made about population parameters. In the last section, in section 6.7, where we looked at the outcomes of the NFL teams that won in overtime, we assumed that the coin toss didn't matter, that each team had an equally likely chance of winning the game. But whenever we ran the experiment, assuming that P, the probability of success, is 0.05, the chance of getting those results that we got was 0.03, or 3% chance of getting the results we got, assuming that each team had an equally likely chance of winning. We got the 235 wins out of 431 games. We can't argue that we didn't get that. We did. But the chance of having that happen, assuming an equally likely chance of winning, was so small that we say, well, the probability of winning then has to be wrong. Because we got the results that we got, 235 wins out of 431 games. And if coin toss didn't influence the outcome of the game, because the probability of getting a head or a tail on a coin is 0.5, then the probability of winning the game should have been 0.5. But the chance of that happening was so small, we said that there must be something there. There must be something to it, that the coin toss does influence who wins in overtime. We're going to be doing tests of hypotheses and investigating claims. We're going to introduce methods for estimating values of important population parameters for proportions, means, and standard deviations, and present methods for determining sample sizes that are necessary when estimating those parameters. If your sample size is too small, your results will be biased, skewed, or invalid. We've got the heart and soul of statistics coming up in Chapter 7, and I want you guys to really pay attention and ask lots of questions during this chapter. So please finish your homework from Chapter 6, read what it is that you're asked to read in Chapter 7 before you come to class, and we will start with 7.2 then on Thursday.